Howdy everyone. Got one more quick module for us here. It's not nearly as complex as some of the stuff we've been working on in the last couple weeks, but nonetheless, it's interesting and worth knowing. And so as an introduction, minimize myself here. Pretty often when you're looking for spatial data, you find something that is a map, and so it clearly is data that has spatial meaning, but you can only get it as an image. You can't actually get it as the spatial data itself. Maybe no one went through the trouble to make the data available. Maybe it's an older map. Maybe there's a format issue. And so what you have to do is you have to take that image and you have to georeference it. You have to add the spatial information back into the bottom of the map. And so this image here, this is an example of an old map that I found that I georeferenced in order to get the data out of it. You can see it has all these different polygons representing a fire that burned in a particular year. This is up in the mountains of Colorado. So there's a ton of information in here. And what's even better, if we zoom in, we can see, if anyone knows Colorado, this is sort of over in the area by Long's Peak. We can see it's really a high resolution data set. There's this 1978 fire here. I spent a lot of time walking around this landscape, so I can attest you really can see that burn. It does stand out from the much older surrounding forest. So really a lot of information here. But for the life of me, I could not find a source of this as spatial data in a format that any sort of GIS software could actually read. All I could find was this image. So I had to georeference it. I had to take just a plain old image and turn it into spatial data. So that's what I'm going to be talking about today. And just to keep things interesting, instead of giving you a practical data set like this one to work with, I'm going to give you a sort of more whimsical example to dig into. But I'll talk about that a little later. This map also, I will say, was not particularly easy to georeference because there's not a ton of landmarks on here. The key to georeferencing is finding a point on the image that you want to georeference and then being able to find that exact same point on the map. So I was able to use some peaks and some distinct points on ridge lines, and then the tributary junctions and the rivers. And then this boundary, I forget exactly, this might be a boundary between Forest Service and other land ownership. So you got to sort of pick what you can in terms of landmarks to georeference. Ideally, a map with things like roads or other human infrastructure. It tends to be drawn quite accurately, so those can really come in handy. And then another thing I'll say about this map, well, it's clearly a map, but they don't give us any information at all about it. I mean, again, I know the landscape here well enough to say that north is up on this map. Beyond that, got no idea. What's the scale? Hard to say. What's the coordinate reference system? Who knows? They're certainly not telling us. So we really just have the information in the image. We have nothing else. There's no metadata to work with here. But fortunately, when you're georeferencing, that's really all you need. You can just start with an image and go from there. So I wanted to show this as a sort of practical example of how you might use georeferencing to actually get some good usable data. The example I'm going to walk through today is a little bit simpler just so it goes quicker. And then I'm going to ask you guys to do a little georeferencing exercise that, as I said before, it's the same process. It's maybe a little bit less of a useful piece of data, but I think it'll be fun. So with that, let me get myself out of the way here. Okay, let's pop over to Q. Okay, so Q has a built-in georeferencing toolkit. It's here under raster georeferencer. Unfortunately, it's a little bit buggy. That's new to this latest edition of Q. It seems like it doesn't get along with some of the other changes that they've made. Um, and so the workaround is that if you work in a completely fresh QGIS environment, the georeferencer seems to work perfectly. But if you try to have it coexist with all the other plugins that you've been using and all the other data that you've loaded, then the georeferencer seems to be pretty buggy. So we need to go a step further than just opening a new project. We need to create a new profile, not a thing you do super often, but fear not, when we create a new profile, it's going to be empty. We're going to use it to georeference, but then you can go back to your default profile that you've been using thus far in the course, and you'll have all your plugins and it'll know all your projects and everything. So here under settings, user profiles, we're going to create a new profile. You see, I don't use different profiles a whole lot. I just have the default profile. To be honest, I suppose you could have it set up for multiple users. Maybe that's the purpose of profiles. But it does have this extra purpose where we can get a really clean QGIS environment. So new profile. Give a name. I think Q is going to open a new window here. It'll take a moment. They'll probably fix this bug in the next version or two. But fortunately, there is the workaround here. Okay, so here's a new profile. You see there's nothing at all, like there's no recent projects. If I sort of look, all the plugins that I would have installed, like the quick map plugin that lives there in the web dropdown, that's not there. None of the plugins are installed. It's basically a totally fresh installation of Q. So trying often, if you're having something be persistently buggy, trying to run it under a new profile can be a good way to figure out what's going on. And again, it does seem to solve our issues here. So I need to do two things. Firstly, I'm going to start a new project. And then I'm going to go down here to the bottom right. And I'm going to make sure I know what coordinate reference system I'm using for this project. I think it doesn't really matter. I just need to know what it is. I think I'm going to go with 3857. Yeah, that'll work just fine. Again, whoa. Yeah, that's right. Okay. Doesn't particularly matter what coordinate system you use. You just need to use one that that you know what it is and that you can stick with through the process here. And then one more thing I'm going to do, I just need to add a base map in. Normally I might do that through the Web Map Services plugin, but I don't have any plugins here. It does seem like they gave me access to one basic base map. Seems to work. So I'm going to zoom in here to Helena. And again, the critical component for georeferencing is being able to identify features both in the map you're trying to georeference and then also on the the base map or whatever data set you're trying to georeference it to. So just using this basic OpenStreetMap layer as a base map may have some limitations. We'll see how it goes. I don't know if it's going to have all the right details to help me pick this out. And as you will see in your own challenge this week, you may have to dig through some layers, some base maps creatively to try to find geographic features that you can actually reconcile between the two maps. Okay, so kind of zoom into Helena, and then I'm going to open the georeferencer. Everything's opening up on my other screen. I'm sure everyone has noticed by now that QGIS is a little fussy about windows. They sometimes pop up where you don't expect them. So here's the basic georeferencer window. This button here is to open a new, it says open a raster, but really we're just opening an image. One could say we're turning an image into a raster, as in we're adding the spatial component to the image. So we'll be using that button here in just a second. This one, once we have the data we need, this one actually runs the program. You can generate a script, which can be helpful if you're doing georeferencing a lot of similar images. We won't be using that today. You can load and save the georeferencing points. That'll make more sense in a moment. This is the add a point tool, remove a point, move a point, so you can edit them after the fact, and then just normal zoom in, zoom out, move around kind of stuff. These tools can be useful for really bringing out the contrast in your map. Essentially stretching the color palette to give you the maximum contrast for a particular part of the map that you're zoomed into. And then this guy here, the transformation settings. One thing that is absolutely critical is that we set the target reference system to the same reference system as the one of the map that we're georeferencing to. So let me just minimize this real quick. So in this coordinate reference system that I'm in, 3857, we can see these coordinates down here. You know, they're obviously in meters based on some particular definition. And our georeferencing is based on those coordinates. And so it's critical that the image that we georeference, it knows what coordinates we're giving it. So, oh, now it's huge. Okay. So again, that'll make more sense in just a moment. Let me open an image first here. Oh yeah. Fresh QGIS installation has no idea where it is. That guy, okay. Oh, you can see I already tried this once. Hang on just a second. So I accidentally opened the image that I just georeferenced while I was practicing this. So let's just grab a different copy of the same thing. Okay, so we've just got an image. So this one's a little bit challenging. At first glance, one thing that's going for us, it is clearly a map. But beyond that, you know, we're going to need a fair bit of information to take this from just being a map to being actual spatially referenced data. And furthermore, this is a picture of a sign that I took with my phone. So, you know, my phone wasn't perfectly perpendicular to the sign, so we have some distortion here. You know, you can see this sign. I guess I didn't measure it, but I would assume it's actually square. But the image is definitely not showing up square here just because of the perspective. Then again, as is typical with maps, we have absolutely no information about the coordinate reference system. Interestingly, they do give us some scale information here, although it's not particularly useful to us because I don't really know what 1 inch is. on this image anyway. So sometimes georeferencing is called rubber sheeting. And that's because you're taking the image and you're sort of stretching and distorting it until it lines up. And I'm choosing this one because we're going to have to distort it a little bit in order to get everything to line up just right. So double check these settings are right. Yep, project 3857. And then there's this transformation type option. If anyone's interested, I can give a lot more information on this transformation type, but it's you can go pretty deep in there and it's not always helpful. But the general idea here is that for a map that you're like, the simplest possible georeferencing would be a map where you knew the coordinate reference system and you knew the scale and you knew the orientation. And so all you really had to do was just place this image on the map, and then you could figure out everything else from there, right? But typically that's not the case. And so you can allow the georeferencing tool to use simpler or more complex transformations to take this image and to lay it onto the map. And so the map we're looking at here, it's a little bit distorted, but it is a modern map, so it shouldn't take too much effort to get it to lay on the landscape appropriately. And so we want a transformation that allows a sort of intermediate level of complexity. And so there's of all these different options, linear I would only ever use for the simplest possible georeferencing tools. Usually I use polynomial 1, which is a first order polynomial, or polynomial 2, which is a second order polynomial. And I choose that based on the how distorted, essentially how confused the georeferencing process is going to be. So in this case, I'm going to go with polynomial 1. If I was working with a really old map where I didn't trust that the map was actually drawn that accurately, and if I was willing to select a lot of training points to complete the georeferencing, then I might select polynomial 2. If I was working with a map that had gotten some wrinkles from water and then gotten scanned and sort of had the wrinkles showing up and causing some crazy persistent distortions across it, then I might pick polynomial 3. But it's the same trade-off here as anytime you're fitting a model to data. The more complex the model is, the model in this case for georeferencing this image, the more complex the model is, the more data we need to feed into the model in order to have it work. So I'm going to pick polynomial 1, and we'll see how it works. For your project, I would probably recommend polynomial 1, but you could give it a try with polynomial 2 as well. Okay, and so that's all we need. The output raster, it's going to save it somewhere. I guess I should look where that is. Could be somewhere really strange. Oh no, that's right next to the other one. Okay, that'll do. And then you can save the points. Selecting this will save the points, which is probably a good idea. I'll go ahead and select that. Load the map in QGIS when it's done. In my experience, that doesn't work anyway, but we'll go ahead and click it and find out. Okay, so let's get going with this. Got our settings good. Again, the critical part here is that the reference system is the same as that of the coordinates that we're going to be clicking on. Okay, so I know this area reasonably well because I live here. I should say I took this picture because it describes the area that you're not allowed to camp in for the national forest that's close to town. And I do like wandering up in the hills and camping, so I should probably know this. But of course, whenever you need this map, you don't happen to be standing right next to the trailhead. Hence the picture in georeferencing. So I'm going to zoom around this image and try to find specific locations on the map that I'm very confident I can find on the base map as well. So some of them are going to be like this junction between these two roads here. Again, you can see this is a cell phone picture of a trailhead sign, so we're not exactly working with the best resolution here. So I'm going to click right there at that road junction, and then it's asking me what the coordinates are. Well, I don't know what the coordinates are, but I'm going to click on this From Map Canvas button, and because that box is checked, it's going to automatically hide that window. And now I'm going to go find the same road junction right here. Okay. So now we've got one line, one georeferencing point. In the source X and Y, these units are just pixels because there is no spatial unit to this image just yet. And then in the destination, these units are in the CRS that we're working in. This is essentially the difference between the specified and the modeled location. And at the moment, we've only given it one point. And then this is the residual. How much distance is there on this image between, the point we clicked and the best job the model can do to fit that point. Since we only have one point, the model's working perfectly. We told it that point is there on the map where I clicked, and it said, okay. But as we get a couple more points, we'll start to see we can get the top of the mountain. Yeah, I think that's the top of the mountain. Okay, so we got two. We can still tell we're vastly overfitting this model because the residuals are basically zero. Like anything in statistics, when your residuals are zero, your model doesn't tell you anything. It's just an exact reflection of the data that you put in. Let me see if I can get some of these. So I'm trying to move around the map. Ideally, I'd like to get a couple points like in every sort of quadrant of the map. That's going to be a little bit hard because I'm not sure there's a lot that's real distinct down there. But some of these property ownership boundaries might work. Of course, you can see it's, not only is this a cell phone picture of a signpost, but the boundary line is humongous. So I'm just going to try to click in the middle of it. And that's that one. There. Okay, so still no residuals, so our model is still radically overfitted. Find some streets here. How about Volter and Hayes? Okay, so now we have enough points that we're actually making the model work now. So this first order polynomial is no longer able to perfectly fit all of the points, which is what we would expect, right? Because in part because my clicking is probably not terribly accurate on this poor quality image. But it's telling us our residuals in pixel units here. And we'll sort of keep track of this as we go. Because if we end up with a number of points with low residuals and then one point with really high residuals, well, we might want to take a close look at that point with the high residuals because good chance there's an error there. And you can go back and revisit a point and delete it or move it. So let's do a couple more. Again, I'm trying to sort of move around the map, get a lot of different things, get points in a lot of different areas. That might be 11th and Davis. If I can find that. Okay. You can also see the line that's showing us the scale of our error here, right? Because the software is distorting the image as best it can to match the points that we're giving to it, but it almost inevitably it can't do them perfectly. So it's really nice to have it display the error. What else do we got? Oh yeah, there's a water tower here. That's pretty clear. Oh, there's not a water tower on that map. Okay. So again, that distance, for my purposes, that distance is pretty reasonable. We might be about one city block accuracy. Let's see if we can find anything else up here. I'm sort of skeptical that we're going to see this on the map. Let's try this corner of land ownership. Oh, geez. I'm just going to look at that again and see where it was. I don't know. I think that one's not working. That looks quite different here. There's some part of that road. So I'm going to cancel that one point. There's a road coming up here somewhere. Must be that guy. How about we try right in, oh, that's pretty close to her. Let's try the point of that switchback. See if I can find that. Right there, yep. I'm sure you're all just riveted watching me click on points on the screen. But it's kind of cool. As it develops, it shows you the error in real time. Shows you which points down here, which points are off, and which way. Of course, there's no absolute truth. They're just off from the best it's able to fit the model here. I'd love to get something up in this end, but I don't really see it, and I don't trust that the trails are drawn the same. On the different maps. Well, there's a trailhead right there. I can see the trails coming in. I'll be able to find that one on the map. let me just get one more point. I can get something over here. Oh, geez. Some of this is just dirt or bird poop or something that's actually stuck to the sign itself. I should have cleaned off the sign before I took the picture. Maybe that will exist. I think that's going to be that guy. We'll see. So this one I'm not too sure of, so I'm going to sort of look at the residuals and see. Drop for me. Okay, there it is. That one's a little bit far off. 119. Yeah, that's by far the worst point I've done. So I may delete that one. Do I actually delete the point? All right, well, we'll roll with it for now. So now that I have 8 points, at least one of them is not very good. There's one other thing that we can sort of look at, which is the effect of the transformation model that we use. So again, we're on this polynomial 1 model because we don't need to do that much to transform this map or to reference this map. But we can see if we move to the higher order polynomial model, which has more degrees of freedom, by definition, it's going to be able to do a better job of fitting all these points, but that doesn't mean that it's actually going to produce a better map, right? It could just do a better job of representing my sloppy clicking. So all the residuals went down, right? I added more degrees of freedom to the model and all the residuals went down. That's how the model works. The model now is capable of incorporating, more of this sort of nuanced description of what is where and distorting this image in more ways. But to be honest, I don't think that makes it better. We could take that to the extreme here if we went to the highest order polynomial. And we don't even have enough points for the third order polynomial, right? The model is still fitting absolutely perfectly because we don't have enough training data for it. Now I'm going to stick with polynomial 1. As a rule of thumb, again, if it's a modern map, it's not wrinkled. You didn't like find it in a jar on the beach and pull it out and flatten it to scan it. Polynomial 1's probably pretty good. If you're really working with some weird older maps, polynomial 2 could be worth a try. But again, the more terms in the model, the higher ordered the model here, the more training points you need. Okay. So back to polynomial 1. That 1 point's a little bit bad, but frankly, all the points are a little bit bad because this map is kind of terrible when you zoom in. So I'm just going to, you guys don't need to watch me click on points anymore, so I'm going to go ahead and run this. So it's a good idea to save the points. If something goes wrong when you're running it, then you have access to them. You could load them in here. So I'm going to go ahead and save the points. Likes to save them as a dot points thing, which is slightly interesting, but I'll trust it. Okay, and now I get to click the green button. Should take just a moment. All right, raster was successfully georeferenced. So I am going to close the georeferencer window. And what do you know? Here it is. Um, so it's pretty funny, right? It brought the whole image in. If I was really doing this right, I'd probably start by cropping the image down. Um, but we got the whole image here. We've got the signpost and everything. Um, and at a glance, it seems to be in about the right spot. If I sort of turn it on and off, it's close. One thing that can be handy here is just to make your image partially transparent. So, again, it's kind of hard to judge because the image is so terrible, but seems to be following the main features reasonably well. It does look like I'm off a bit there. So if I were trying to continue working on this, now that I see the two laid out on top of each other, I can really see like where I could have done better, right? There's a couple of these different corners of the property boundaries that I really could have gotten quite a bit better. In fact, that one's interesting because I thought I'd clicked there, but didn't seem to do enough. And I could also, the georeferencing is quick enough. I saved the points. I could open it up and run it again with the second order polynomial and actually see if the resulting map looks a little better. So it's a sort of like a lot in GIS, it's sort of an iterative thing where you keep poking at it until you get it right. And I would say I did not do an absolutely fabulous job here, in part because I'm quite talkative enough as it is, and you guys don't need to watch me click on the screen all night. I'm just trying to get you the basic idea here. Anyway, so the accuracy is not great, but fundamentally, we did it, right? We took a poor quality cell phone image of a map and we actually turned it into a raster, right? If I turn off the base map just to emphasize this, much of this has no meaning, but the map part of it is actually a raster image, just like every other raster image that we've worked with all semester. And we could even analyze it in some particular ways if we want. The only information it contains is its color. We could also use it to draw polygons of this particular area that you're not allowed to camp in, this no camping boundary line, which I might do, although I might go back and revisit my georeferencing points first because something has gone badly wrong up here. So if anyone wants to dig deeper into the sort of the details of the different transformation models, there is a lot to it, and it is kind of interesting. I'm not getting in it at the moment, but if you want to, hit me up, and I'd be happy to give you some resources there. But generally speaking, this is the kind of tool where, as long as you have a sense of the sort of accuracy that you need, it just takes some patience to get it to work. There's no real expertise beyond just taking your time and being willing to go back, find some additional points and refine some points as you need. So with that, let me introduce your challenge. I'm looking for something that we lost a long time ago, which is the lost city of El Dorado, the city of gold. And I'm hoping you guys can find it for me. There we are all the way. So this is the best map I've been able to find. We're sort of in the north part of South America right now. And there's a lot going on here. My Spanish isn't very good, but there's a couple things I am able to identify, like the Amazon River. There's likely some features on this coastline that are distinctive, some of the islands up here. Um, I am not sure the locations of these mountain peaks is going to be a whole lot to work with. Um, but it seems to me like that's going to be the rivers and the coastline, that's going to be the main parts here, which is going to be tough because you might not have a lot of good points in here. It's probably because the person who is making this map seems to have gotten attacked by a headless man at some point in there. So, anyway, strange things. Oh, there's also lions in the Amazon. I didn't know that. Strange things happen. One of the strange things is there's this lake on the map, and I was reading up on this a little bit because I thought it was interesting. That's a humongous lake to draw there. I mean, I know um, our courageous cartographer here was surely dazzled after his visit to the city of gold, but to draw a huge lake where there in fact is none, that's a large error to make. Um, Turns out there's actually some historical evidence that there was a lake there historically, and that it has since drained. So I'll be interested to see as you do this if you can in any way distinguish this historical lake area from the area around it. My guess is that the the Amazon rainforest comes in so thick that a lake that's been gone for 300 or 400 years. We have a date here, 1594, 95, and 96. Um, Sir Walter Raleigh. Interesting. Okay. Why is it in Spanish then? Um, so it's actually possible that there was a large lake in the interior there that has since drained. At any rate, that's what Wikipedia has to say about it. So right here, you see this little red city. That is our guy. That is what we're looking for. This is all the way. Whoa. Sorry, having trouble with the zoom. Um, that is the city of El Dorado. So your task for this module is to georeference this image, um, and georeference it to any coordinate system that you want, just so long as you know what it is. And then I would just like you to place a point um, on this lost city of El Dorado and share it with me. Um, and once the semester's over, I'm going there. I'm going to go find the lost city of gold. Hopefully, I won't see any headless men along the way. That's a little strange. Um, and it probably goes without saying, but I'm hoping that this module is equal parts fun and educational. And if we in fact fail to find the lost city of El Dorado, we won't be the first ones. So there'll be a couple more details in the text. That is the gist of georeferencing. Again, a really useful tool, useful for finding lost cities of gold, and also useful for, essentially transcribing some old map that you found on the internet or in the library. I mean, think about how many maps are in a library that have no modern GIS data behind them. Well, this is the technique by which we can take a map and turn it into modern GIS data. And if you have a little more patience than I have at the moment, you can do it quite accurately. Of course, with this map, our accuracy is going to be very much limited by the accuracy of this drawing, so we won't worry ourselves too much. um, if everything doesn't line up just perfectly. Okay, that's all from me for the moment. There'll be some more details in the text. Thanks for watching.